Hi, everyone. My name is Lakshmi Alagappan, and I am a director at E3, which is a consulting firm based in San Francisco, California. Today, I'm going to be talking about some work that we're doing for the California regulator, the California Public Utilities Commission, on integrated resource planning, which is a stakeholder proceeding that the California PUC is holding right now in hopes of creating least cost portfolios to meet long-term policy in the state. And if time permits, I'll talk a little bit about the Resolve tool, which is a renewable energy solutions tool that's being used to develop these portfolios. To provide a little bit of context, California has very aggressive energy policy right now that's driving significant renewable adoption. It has a goal of reducing greenhouse gas emissions by 40% below 1990 levels by 2030, and that's supposed to be accomplished by a 50% renewable portfolio standard by 2030, and doubling of energy efficiency in existing buildings by then as well. There's also legislation that is being considered at the moment of increasing those RPS targets up to 100% by 2045, and so we're expecting to see continued growth of renewables in the state. In addition, there's a lot of distributed resources that are coming online as well. We have a strong net energy metering policy, which is driving a lot of adoption of rooftop solar. We're expecting that to get up to potentially 20 gigawatts by 2030. And as we look out to 2050, the goals are to get below 80% reductions relative to 1990 levels by 2050. And so this is just a visualization of what those goals look like. And if we take stock of where our current policies are, we expect to meet the 2020 goals, but fall just short of the 2030 goals. And so the policymakers in California are thinking about how much further can we push the different levers in the state to meet those 2030 goals and 2050 goals. And so there are 4 key pillars to achieve greenhouse gas reductions that are needed to meet these goals. And the first one is increasing energy efficiency and conservation in the state. The second is fuel switching. How much can we sort of switch to electric vehicles and decarbonize some of the fuels there? Decarbonizing the electricity sector itself. A lot of the renewables that are coming online now are helping that, but like I said, the regulators want to push beyond 50%. And then decarbonizing fuels as well, not just oil, but also thinking about gas. Of these 3 pillars, there's 4 pillars. There's 3 of them that fall under the jurisdiction of the regulator: energy efficiency, fuel switching, and decarbonization of electricity. And so these are 3 things that the California Public Utilities Commission is very interested in and wants to start thinking about how to do least cost planning to achieve these goals, to make sure that ratepayers don't have to pay exorbitant amounts of money to meet the long-term goals for the state. And so they're thinking about defining this as a new planning problem. New RPS targets and greenhouse gas reduction goals are increasing. A lot of the questions around how much dispatchable resources we need to meet load, flexibility requirements, and more, I think what the key question is what's the optimal mix of resources that we need, given the existing characteristics of the fleet as well as the new technologies that are coming online as well. We talked a lot about this over the last couple of days, so I won't spend much time here. But there are lots of drivers for renewable integration challenges, and a big part of what the PUC is looking at in California is thinking about which of the solutions to the integration problem are going to be most cost effective. And so they started this proceeding called the Integrated Resource Planning Proceeding. And the purpose of what I will call IRP is to reduce the cost of achieving statewide policy goals, particularly with respect to greenhouse gas abatement, by looking across individual load-serving entity boundaries and resource types to identify solutions that might not otherwise be found. And so what they're really trying to do is optimize a least cost portfolio for the entire state. Often when you hear about IRP, you think about it for individual utilities. But here, because the regulator really wants to be able to meet the long-term policies at least cost, they thought that it was best to look at it across the whole state rather than at the individual load-serving entity level. And so it's a 5-step process, which starts first at setting the greenhouse gas planning targets. And so this is something that is undertaken by the California Air Resources Board. And they determine how much greenhouse gas reductions need to come from each sector. Then the California PUC takes what is going to be allocated to the electricity sector, and they're starting to create reference plans around how much they think they can decarbonize the electricity sector using different levers. And so they're putting together a reference plan using an optimal capacity expansion tool that we'll talk about in a little bit. And then they're going to share that plan with all of the load-serving entities in the state. Then in step 3, the load-serving entities take that system reference plan and parse it down to their own individual level to say, okay, this is a plan that I can do for my own service territory that's consistent with what the state wants. They send that back to the CPUC to review to make sure that it meets all of the greenhouse gas cost and reliability metrics. And then they will authorize potential procurement for any new resources to meet these goals long term. And so step 2, creating this reference system plan, is using a Resolve model, which is a public tool that E3 has developed for this process, which we'll talk about a little bit now. So Resolve is an optimal capacity expansion tool that co-optimizes investment and operational decisions. It's a linear program that allows portfolio optimization across a long time horizon. Here we're looking out to 2030. We've done cases that look out to 2050. It does fixed costs. It basically looks at the fixed costs of new resources as well as incorporating some operational detail, basically because we want to make sure that we're capturing issues related to renewable integration. And coming out of this is an optimal portfolio that is least cost, that will choose solutions based on renewable overbuild, energy storage, advanced demand response, conventional gas generation, and gas retrofits. So here's an example of what might come out of the Resolve model. We think that optimal solutions are going to be balancing some non-renewable solutions with some overbuild of renewables. And so if you look at the bottom graph on the left here, this is a system that's highly inflexible. The only flexible solution that we have here is renewable curtailment. So that's one end of the spectrum. If you look all the way on the right, this is a system that has built all storage to deal with curtailment. And so that's a highly flexible system. We think for a least cost portfolio, there's probably a combination of both of those things, a little bit of curtailment and some new build of storage or other resources to help with integration. And so this tool develops those portfolios across a number of different metrics. So there's a lot of detail in here. If people are interested in the tool, you can, it's on our website, it's public. It has a lot of detailed inputs on both the demand side, the supply side as well. And how the tool is being used in IRP right now is that it runs a number of different scenarios in there. And so here is 1 through 14 are basically different scenarios that the CPUC is testing to understand what the costs of building, say, here behind-the-meter PV, energy efficiency, advanced demand response, et cetera, look like under these different cases. And so the first one is this base case. This is sort of all basic policies, so 50% RPS. The second one is this out-of-state wind case. So if you allow the portfolio to go outside of the California boundaries, does that actually help your costs? The third is, what if you force the portfolio to build bulk storage, advanced DR, et cetera? And so the tool can tell you how much each of these portfolio costs. The tool can also give you a number of different outputs which help for comparison. It will give you not just the portfolio itself, but the fixed costs of the new investments, system-wide operational costs, how much curtailment is happening in the cases. And this is important, especially in California, because the policy for RPS means that you have to deliver the energy. And if you don't, then you have to go out and either procure another REC or overbuild your renewables. It can also give you greenhouse gas emissions and fuel consumption, which are important for ensuring that you're meeting these longer-term policy goals as well. So these are just some preliminary results from the IRP cases so far. These are subject to change, but I just wanted to give people a glimpse of what the outputs look like. So this is a case where you're reaching 50% RPS by 2030. And so here you can see that the tool primarily selects solar for the most part from 2018 out to 2030. And it's really limited in how much new generation it builds because of two things. One is California loads are pretty low right now. They haven't grown in a long time. We have declining loads for a number of reasons. We have a lot of behind-the-meter PV and a lot of energy efficiency as well. And the utilities in California have overbuilt their renewables to a large degree, and so they have large banks of RECs that are sitting there. And so it isn't optimal to build at this point, given that they have so much in the bank. If we change the target from a 50% RPS to something that's more stringent, like a greenhouse gas goal, here the goal is a 30 million metric ton statewide case, we can see that it forces the portfolio to become much bigger. And so instead of a 50% RPS, it shows that we have to move to something closer to a 70% RPS. In this case, in 2030, it's actually 72%. And this is even accounting for the banking. And so we build solar in the near term, but we find that as we build more and more solar, it becomes uneconomic to continue to curtail. And so we start to add long duration storage in the model as well. We start to displace gas consumption outside of daylight hours as well, which leads to more wind and geothermal development to make up for the hours in which the gas would have been dispatching otherwise. And so these types of scenarios are being run across a number of different sensitivities. And the idea is that the CPUC is going to make this tool available to the individual LSEs to be able to run on their own to create their own portfolios for the IRP process. So next steps for IRP is that the CPUC is finalizing the reference system plan in the next month to be able to give to the LSEs to develop their own portfolios. So we're in the middle of step 2 and step 3 right now. And then by the end of 2018, the CPUC should be able to review all of the IRPs that they got back from the different LSEs. And hopefully by 2019, they can start a procurement process to ensure that we have all of the needed resources, whether they're renewables, conventional resources, storage, et cetera, in place to meet those long-term goals. And I have more details on Resolve if people have questions, but I think I'll end there for now. Thank you.